In the previous video, we mainly focused on how to edit faults manually. So in the 3D window, um, let's put the faults on it. Let's put the faults on it. So that's our collection of faults, and what we did was mainly just to sort of connect all the faults manually, and then did some editing. Right, for example, try to actually push the pillar grid to uh, sort of consistent with the horizons, right? So if we have a base, we have a top eve, then we can sort of adjust the height of the key pillars so that they can sort of go through, cut through all the horizons, right? There are also a few buttons that allow us to actually do the editing automatically, right? Once we have understood how to actually do fault editing manually, it's going to be relatively easier for us to actually understand the purpose of those buttons that's going to allow us to do fault editing sort of automatically, right? So the first thing we're going to sort of take a look at is actually this underneath the structural modeling tab, we have a fault model operations button, right? We looked at the edit fault model button, right? If you click on it, it's going to give us this tool palette, right? And then there's some buttons that allows us to edit the pillar. Now let's look at this fault model operations button. If we click on it, it's going to give us this dialog box. This dialog box actually has two sections, right? And then on the top part, it's cut, extend pillars. And then on the bottom part, it's automatic fault connection, right? So we were doing manual fault connection, right? But this part of the box allows us to connect the faults automatically, right? But those automatic capabilities actually also have limitations. Later on, you're going to see the limitations, basically. But now let's look at the cut, extend pillars, this part. And this part allows us to specify a top limit and a base limit, right? And if we actually enable both, and then for each of the limit, you can select a specific surface. Again, you see the blue arrow here, so which means that you can actually select a particular surface from the input pane, right? And then there's also a choice for constant, which is going to give you a constant, which allows you to specify a constant z value, right? So let's use surface. And then for the top surface, let's use base, which is actually base Cretaceous. So you have to sort of select a surface object from the input pane. So this kind of a contour object is not going to work. It's not going to allow you to do that. So let's give it a try. I haven't tried actually. So it's not allowing you to do that. Okay. So accept surface or surface attributes only. So we have to sort of select this surface. But this surface was actually constructed from those contour lines. This is a contour line data. This is surface data. And then base limit, let's use top eve as the base limit. And then we're going to apply this kind of truncation to all pillars, and then cut by the limits, extend to the limits, right? And then we don't want to include the truncated pillars. And then you have a specification for mean pillar height. So you don't want to cut the pillar to below this threshold, right? Sometimes the horizons can actually sort of merge together, right? We know that base Cretaceous is actually an erosional interface. So if you actually try to display it, at some points, at some locations, they actually have a uh, they actually merge together. If there's a faults, if there are faults at those merged locations, then if you just enforce this kind of cut by limit and extend to limit, then the height of the pillar could have a very small height, right? And if that's the case, you can use this threshold to so the minimum pillar height. Let's give it like 100, and then we can just so as soon as you click on this cut extend button, for now the undo button is grayed out, right? But as soon as you click on cut and extend, once you have sort of applied the cut and extend, you can sort of see lots of the 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 height of the pillar has changed, right? And then you have an undo. The undo button lights up, right? It becomes effective. If you don't want to sort of apply this particular effect, you can undo it, and then all the pillar is going to go back to the original height. Maybe I should just um, this is a top view, right? This is the top view. It's a cut, right? That's sort of the effect, right? Let's undo it, but let's also look at the bottom, see what's going to happen to the stuff in the to the stuff to the folds at the bottom, right? You can sort of see the top Eve interface is actually very rough. It's got huge variations, right? Suppose suppose we also cut and extend, right? Now you can see that the folds are indeed following the trend of the top Eve interface, right? And here we are enforcing a 100-meter minimum height, right? Let's maybe let's still undo it, and then maybe let's increase it by to like 150, right? And then let's cut, right? Maybe that's a better effect. And maybe it's not. Maybe it's not. Let's still undo it. So let's change it back to 100 and see yeah. But for some reason, you still have some pillar that's sort of sticking way out of the horizon, right? And if you look at the bottom, it's like it's the same thing. But anyway, let's undo it. Let's undo it. But if you would like to actually truncate the folds, you can sort of play with this part of the box and try to find a good configuration. But eventually, you may still have to sort of manually try to adjust the height of the pillar, right? And then there's another portion that's automatic fold connection. Automatic fold connection. So let's take a look at this part of the dialog box, right? Let's find a good example. Let's find a good example. Let's try to use these two folds, right? The blue fold and the yellow fold, right? And let's convert the cursor to the picker. This is what? This is the boundary fold. This is the boundary fold, and then the yellow fold is main fold with the 3, right? So let's just display these two folds. Boundary fold and then main fold with the 3. Let's just display these two. So it looks like they are actually merging together, right? They're actually merging together. So let's see if we can connect these two folds by just using this automatic connection. So this automatic fold connection has a checkbox that's only use visible folds. So if you click on this part, click on this checkbox, it's gonna just do the connection on the two faults that's inside of this 3D window, right? Only the visible faults. If you uncheck it, then it's gonna apply to all the faults inside of the faults folder, right? And that's not exactly what you wanted, because you got truncating fault here. Right? A truncating fault pretty much has to be edited by hand. The automatic connection is not going to work for the truncating board. It's really complicated. So it's always a good idea to just enable the only use visible faults checkbox, right? And then let's just use the default values, and then click on auto connect. And you can sort of see the shape of the faults are very strange, right? After the connection, the shape of the faults are actually very strange, right? And that's not what you wanted. It's not a good connection. It has changed the shape of the faults in a bad way, right? That's not what you wanted. So let's click on undo, right? Let's click on undo. And one of the problems that we're having is probably just these two pillars. The two pillar on the blue fault seems to be too close to each other, and then the yellow fault seems to be bending towards the blue fault. So when you are actually doing the connection, it's not exactly the pillar on the edge of the blue fault that's being connected. It's actually the one that's right next to the edge, right? It might be so maybe it's a good idea to actually just delete the interior pillar that's right next to the edge, right? So let's click on this manipulate pillar's shape points, and then let's just select this particular pillar, right? And then in order to delete this pillar, we can just click on we can just press the delete key on the keyboard. Right, now we've deleted that pillar, and the shape of the fault didn't actually change much. It's just minimal changes, right? Let's take another view at this, right? And now let's apply auto connect again. Looks like it's not actually changing. It's not really changing because the distance between this fault and this pillar is kind of larger than 150, right? So let's increase this extend distance. Let's change like 250 or something, right? And then let's click on auto connect. Right? Looks like it's okay now, right? Looks like it's okay. These two faults has been connected together. Right? But if you undo it, you can sort of see this pillar on the yellow fault was moved over to match with to connect with the blue fault, right? So you have some kind of a movement. You may want to sort of move it back. Right. Let's still try to actually move this pillar back a little bit. For some reason, it's not allowing me to actually move it. Let me redo it. Yeah, maybe that's good enough. So now these two faults have been connected together using this kind of auto connect capability, right? If you have lots of faults and lots of these kind of simple connections, then you can just select those simple those faults inside of your sort of 3D window and then apply this auto connect. It could save some manual editing, right? If the connection is sort of simple enough. Yeah, let's close this box. And then let's put all the faults back. Right. All the faults back. Let's see all the faults. So if you look at this particular sort of yellowish green fault, you can sort of see the pillar are kind of distributed unevenly, right? It's not like a very even distribution of the pillar, right? Um, so if you want to sort of make the key pillar sort of spread out evenly along the fault, what you can do is first select the entire fault by clicking on like the top line of the fault, right? Of all the pillars. This is not selecting just the one pillar. This is selecting actually all the pillars on the fault, right? So you can sort of see the entire pillar has been light up. And then at this point, if you just right click, you have a button that looks like that called equal space. So apply equal space to the selected pillars. See, right? And this button is kind of duplicated here. Right? If you click on the context aware ribbon, right? you got here equal space. Right? So if you click on it, then all the pillars are going to be sort of spread out evenly. Right? And this is actually a good thing when you actually do the pillar grading. Right? So why the pillars, the key pillars were not sort of distributed evenly, right? Why is that? The reason is that when we actually imported, not exactly imported, when we actually converted the fault sticks, when we converted the fault sticks into convert to faults in fault model, when we did that, in the dialog box, we selected every nth stick, every fifth stick, right? Every fifth stick. So for every fifth stick, it's going to create a key pillar, right? But the fault sticks were distributed unevenly. So let's look at what's actually the name of this particular fault. It's boundary fault west. So it's boundary fault west, right? So let's turn off the fault model, and then let's look at the fault stick, right? Boundary fault west. So you can sort of see that the fault sticks are actually distributed very unevenly. At some locations, for example, at the beginning, at this part of the fault stick are kind of the distribution is quite coarse, right? The distance between neighboring sticks are quite large, but this part is quite dense, and then this part is kind of sparse again, right? And when we actually sort of converted all the fault sticks into faults in the fault model, it's kind of uniform selection of fault sticks for generating those key pillar. So sometimes you may want to just select those fault sticks by hand manually, right? So you can actually ensure a relatively uniform distribution of fault sticks. If that's what you want, you can again sort of change your cursor to the pick mode, and then you can just select. Oh, it's not the pick mode. You have to sort of go choose this one. Right, choose this one, and then you can when the cursor actually becomes this kind of cross here, you can start to select, right? So as soon as you clicked on one of the fault sticks, it's going to turn white, and at this point you have to sort of hold down the control key. Oh no, hold down the shift key. Actually, it's not a control key. Hold down the shift key. Hold down the shift key, which allows you to actually select the multiples. Right. So you can sort of for the flat part of the fault, you can just use very wide stick distances, right? But for the curved part of the fault, you may want to sort of increase the density so that you are not missing. Oh, sorry, I sort of. Oh, For some reason, my shift key is not holding. Basically, just for demonstration purposes. So that's all the white sticks are the sticks that selected manually, right? And at this point, you're going to see a context-aware ribbon that's called a polygon. And you can select it, click on it. And then you have a convert to. You have a convert to button. And this convert to button has a inverted triangle here. You click on it. Right? And then you can sort of, all those things allows you actually to convert forward, but this one is what you want. It's convert selected sticks to pillars, right? And then if you click on it, it's going to allow you to actually configure the number of shape points or sort of kind of control points on the pillar, and then extra height, that kind of thing. And then fold is it going to create a new, let's just create a new fold, right? Let's click on OK. And then as soon as you clicked on OK, you're going to see this thing, fold 1, right? That's a new fold, right? And let's change the cursor back to the viewing mode. Right? That's sort of the shape of the fold, and we can actually compare it with the boundary fold west, I think. Right? That's the two folds, right? They are pretty much identical, right? But the number of key pillar that's on your manually selected fold is actually a lot less, right? It's a lot fewer. Right? If you compare these two, let's turn off the fold stick maybe. Right? Right. They are almost lined up. They're almost aligned. Right? If you actually try to if you in your manual selection, if you increase a few more sticks here, it's gonna be a better match, right? But let's delete fold 1. Let's delete fold 1. Let's delete it. Right. And there are still a few more buttons that we need to sort of pay attention to. So let's still click on this thing, and then let's select the entire fold, all the pillars. Let's select all the pillars. Right. Again, if you right click in this kind of toolbox, you're going to be able to see this kind of a smooth. This kind of two buttons allow you to actually to smooth the fold surface, right? So this one allows you to smooth the selected shape points in all directions. In all directions means what? In all directions means it's gonna smooth it both horizontally and vertically. So it's gonna make the fold smoother or flatter, and then in the vertical, also in the vertical direction. So, but this one is smoothing only in the Z level of the selected shape points. So it's gonna just make the shape points more or less at the same kind of height, right? And these two buttons are also duplicated here in the context-aware button. Here you have smooth, right? So we have undo button here, right? So let's click on smooth. Right, you can sort of see it's not just smoothing in the vertical direction. It also actually bends the fold so that it also bends the fold so that the fold plane becomes flatter. Right, maybe that's not exactly what we wanted. So let's do a click on undo. Right, but smooth Z is just gonna sort of change the height of the sticks, change the height of the shape points. Right, so it's not gonna shift the pillar laterally. It's just gonna shift the shape points vertically. Right? Again, let's do an undo. Right, and this kind of capability can also be quite useful if we want to regularize all the folds so that the grids can be more regular, right? That's pretty much how we actually uh, do photo editing, right? And there are still some other buttons that I haven't actually explored. I haven't actually explored some of the buttons. Um, uh, uh, suppose we use this small fort as an example, right? Let's select that fort. Let's select that fort. So if you want to select the entire fort and all the pillars on the entire fort, you have to sort of click on the line that's connecting the pillars instead of the pillar itself. And then and then uh, you have we looked at this button, right? When we actually try to connect the forts by manually, right? We used this button before. And then you have this button right next to it. That's add to end, right? So if you click on it, then it's going to extend the fort in the direction of the original fort. So if you click on it, if you if you if you click on it, then it's just going to add one more pillar to the end of it, to the end of that fort. So effectively you're actually extending it. But let's not do that. Let's undo it. Right? Let's not do it. So that's another kind of a useful button for you to actually edit forts. Um, yeah, that's pretty much the most important part of photo editing, right? That's probably the most important part of the photo editing. And now we can actually go to the two-dimensional window and try to actually build the pillar grid. Let's go to the two-dimensional window. Right. Um, so in order to actually build the pillar grid, there are two things that we need to do. One is to actually specify the boundary of the model. Right. For now, there's no boundary. There's no boundary, but you have to sort of specify a certain boundary in order to actually to build the grid. The grid is always finite. There's no way for you to actually build a grid that's kind of extending to infinity. It's not going to possible. It's not going to be possible. So you have to sort of introduce some kind of boundary, right? And another thing that you may have to do is to actually specify the trend of the mesh, right? So you have a truncating fault here, right? And usually you want your final mesh, to be sort of aligned to this truncating fault, right? And at some other locations, you may want to have your mesh to be aligned with some kind of preferred direction, for example, right? Suppose you have an injection well, and the water is going to flow in a specific direction, right? And then you may want to build your mesh in a way that's kind of either aligned or sort of perpendicular to the flow direction of the water, right? So Petrel actually allows you to actually specify those kind of preferred directions of the mesh, and then it's going to build the mesh or build the grid in a way that you sort of configured, right? Um, so the first thing we're going to do is to actually try to build a boundary to build a boundary for the entire model. Um, let's go to the input pane. This time we're going to import one more file actually. So right click, and then import file. And then we're going to select the project boundary. So again, it's an ASCII or text file provided to us, right? And someone has already sort of determined what's going to be the best sort of project boundary, right? And the format of this particular file is zmap plus lines ASCII. So again, it's an ASCII file and it's a line data. And then let's just open it. And then the name is project boundary. Then the type is lines, boundary, polygons, elevation depth, right? The template is going to be elevation depth. And then the line type is not going to be for sticks or horizon contours or anything, right? What you can do is either to select a generic boundary polygon or just use others. In this case, it doesn't really matter actually. So let's just use generic boundary polygon. Yeah, let's just choose generic boundary polygon. Right? And then OK or OK for all, doesn't matter. Let's click on OK for all. Right? If you want to display this project boundary on the two-dimensional map, you can just display it, right? So that's sort of the shape of the project boundary. Right? But in order to actually use this project boundary as the model boundary, right? This is actually in the this data is in the input pane, so it's just the data, right? But Petrel doesn't really know if you want to use this particular data as a boundary for building the model, right? So what you have to do is to actually right-click on it, and then you have a on the context menu you have this thing, convert to grid boundary, right? And then you can select that. Right? And as soon as you select that, you got a new item that's called a boundary inside of your demo model file, right? So far, all our effort is like building the model, fault model, right? So we have lots of faults underneath the faults folder, right? Let's collapse that. Let's collapse. But in addition to that, you also have trends, and then now you have boundary. We're gonna build the trends later on when we actually specify the I and J directions, that kind of thing. But now you have a new object that's called boundary, right? And the boundary has a bunch of sort of yellow boxes on it. Those yellow boxes are actually control points. And you can actually use those control points. You can actually adjust those control points. You can actually change them and delete them, that kind of thing, right? It's again not strategic structure modeling. And then edit for model, right? Use this button, select, edit, add nodes, right? And then you can just say, oh, for some reason, now you have to sort of put your cursor exactly on the node in order to actually drag it, right? You have to sort of aim at it, right? If your click is like not accurate enough, for example, if you just do that, that's just gonna add one more point to it, right? Of course, you can delete it. You can just use the keyboard delete key to delete that point that you just added, right? But if you want to just drag this point, you have to sort of do a really accurate selection, right? Right. Let's sort of try to change it or something. But for some reason, it's not allowing me to why this point is not doesn't allow me to move it. But anyway, that's how you can actually sort of edit this kind of a boundary, right? But there are also other ways for building the boundary, right? Sometimes you would actually prefer to use this kind of fault, or at least at some segment of a fault as the boundary, right? If that's the case, let's delete this boundary first, because every model can have just one boundary. So if you try to create a new boundary, you have to delete the existing boundary first. Let's just delete it. Right. And now let's try to actually build a boundary using part of the faults. So suppose I want to use the entire fault, this particular fault, as part of the boundary, part of the grid boundary. What I can do is that I can select, if I click on the line, or the line between two yellow boxes, then it's going to select the entire fault. And at this point, if I go to the fault model context-aware ribbon, I have this option, this button called a grid boundary, right? So after I selected the entire fault, I can click on a grid boundary, and then you can see that the shape of the fault, the shape of the line actually has changed. You have this kind of a slightly blue or slightly green, this kind of outline to the yellow boxes and the white line, right? Which means that this part of this fault has been set as the grid boundary. And later on, when Petrel tries to create the grid, it's gonna sort of build the grid inside of this particular fault, because this fault has been set as the boundary of the grid, right? And maybe we also want to use this particular fault as part of the boundary, right? Let's click on it again. And then grid boundary again. Sometimes you don't want to sort of use the entire fault as the kind of the grid boundary, right? If that's the case, what you can do is to click on one pillar point, and then hold down the Shift key or Control key and select another point, or Shift key. You have to sort of see. So click one point and then hold down the Shift key and then select another point, right? So now you have two yellow points that's been selected, right? And at this point, if you click on grid boundary, then only this particular segment of the fault is going to be turned into a grid boundary. And this particular part of the fault, which actually belongs to the same fault, right? This segment and this segment are both the same fault, right? But here you are just using portions of the fault as the grid boundary. And then what you want to do is to actually the boundary has to be closed, right? If you just specify these three segments, that's not a closed boundary. So you have to sort of close it. So how do you actually close it, right? You have to sort of draw lines to connect those segments, and then create a and draw lines for those regions that's not bounded by any faults. And how do you actually do that, right? How do you actually do that? When we actually draw boundary lines, what we want to do is to include all the whales inside of it. So let's display all the whales, right? So that we can see where the whales are. So our boundary we may want our boundary to actually include at least all the whale heads, right? To be big enough to include all the whale heads. Another thing that we can use as a reference is the project boundary. So if we want to display the project boundary, right? So our boundary for the grid may want to be sort of inside of the project boundary, right? We don't want to sort of go beyond the project boundary, which may not be necessary, because it's just going to waste a bunch of computing resources later on, right? So now we can actually start to draw our boundary. We can use this button, create external grid boundary segment, right? We can click on it, and then we can just connect these two pillars. Click here, and then double click on this one, and then press the escape key on your keyboard. So these two pillars are connected, right? You have one boundary segment. And then go back to do that again. Click on this pillar, and then double click, and then press the escape key. So you get another segment, right? So B8 and B2, the whaleheads here are kind of like a, it's a, if I connect these 2 points, B2 and B8 should be inside of our grid, right? Let's just do that. Yeah, that looks like it's a good boundary, right? But maybe later on we can sort of try to make some edits to it, right? Now let's just do this kind of connection. If we just do a straight line connection, is that going to be good enough? Maybe later on we can adjust it. But now this time we have to sort of introduce one additional point, because we want to include C6 into our model. So let's click once, and then we make a turn, and then close the polygon by double click. Now we've got our simulation grid boundary, right? And if we would like to actually make adjustments, again, we can actually click on this click on this button, and then we can just maybe you can we can add a few more points here. For some reason, it's not allowing me to select the line or something. Oh. Let me turn off the wheels. Oh, it might be just a delay because my computer is kind of slow. So let me turn off the boundary. Can see things better. It's not allowing me to change that. So let's just work with that. Let's just work with that and see how we can actually. Maybe it's not a good idea to actually use this segment as a grid boundary, right? Because if you have to use this segment as a grid boundary, the shape of the polygon seems to be kind of strange, right? So if I click on remove boundary, then this part is no longer a boundary. And then maybe let's also do that. Let's remove boundary. And then that's how you can actually sort of create a boundary for building the grid, right? And then sometimes you need to actually specify a certain segment of the fault as the I direction or J direction. The I direction and J direction are kind of used for Petrel to actually recognize what might be the preferred direction for building the mesh. So usually the J direction should be kind of a north-south, more or less. And then the I direction should be more or less east-west. So the I direction and J direction should be more or less perpendicular to each other. So if we want to use a certain segment of the fault as the I direction or J direction, what we can do, for example, if we want to set this part of the truncating fault as the J direction, we can so first pick a point, right? And then hold down the shift key and pick another point. Right? And then we can just click on set J, right? So this direction is going to be set as the preferred J direction, right? So the mesh is going to be more or less aligned in this direction vertically. Let's also set this part of the fault as the J direction, right? hold down the shift key and then click 2 points and then set J. Right. That's also a preferred J direction. And sometimes we would also like to actually specify the I direction, right? So if the J direction is like this kind of direction, right, the I direction should be more or less perpendicular to it. So it should be more or less horizontal. But we cannot really find a fault or existing fault that's kind of more or less horizontal, right? So in this case, we can add manually a trend, right? This time, let's just add a I trend from that goes from this point to this point, right? So if we want to manually add the I trend, we have to use this button, add new trend, and then again click and then drag. Not drag, just click once and then to the end point click double click and then escape key to actually stop the connection. And then the I direction are usually displayed as in green, and because it's not an existing fault, so it's actually drawn as a dash line. It's drawn as a dash line here, right? And then as soon as I actually added a trend, the trends directory in the model is no longer empty. You have something here. That's trend 1, right? That's this line here, this dash line. That's trend 1, right? And then sometimes you may want to sort of partition the entire model into different segments. And if that's the case, you can draw those trend lines and then just specify them as a segment boundary, right? So let's pick this line. Let's pick this line, right? Let's make this line active, right? Right, and at this point you have this button called segment boundary. Right? If you click on it, then you can sort of see the color or the shading of the green line becomes slightly changed, which means that this line is going to be used as a segment boundary. So this portion of the mesh is going to be kind of treated. Um, uh, so later on, when we actually try to compute the kind of some statistical values, right? For example, how much oil is actually inside of this particular reservoir, we can actually compute them separately. Right? This is one segment. We can compute the statistics just for that particular segment, and then treat the rest of the mesh as another segment. Right? We can sort of compute those statistics for each of the segment of the grid separately, which will give us a better idea about how the hydrocarbons are distributed. And I think that's pretty much everything we want to do with before we actually build the grid. And once we're done with these configurations, we can actually click on the pillar grading button. We have the pillar grading button right here, right? And this button is also duplicated under the structure modeling ribbon, right? So you have pillar grading here, and then you can click on it. So now it's going to give you a dialog box, right? For now, we are just going to look at this settings pane. We have lots of panels, right? But let's just look at the settings panel, right? So for now, we're going to create a new 3D grid. Of course, we can change the name, right? 3D demo grid or something. Oh. Right. And then you can specify the increment in the I and J direction. If you reduce it, it's going to create a denser mesh. But let's just accept the default for now. and that's pretty much all the most important configurations for us right now, right? And then we can just click on apply. All pillars, the problem pillars are selected. The problem pillars are selected. Looks like I have some problems. So let me stop the video at this point, and I will try to correct those errors in the next video.